Okay, so we're working on the Supernal place. I've got space in my backpack to pop this air taxi. It's going to be awesome.
For a long time, urban air mobility has been an industry of PowerPoints. We are trying to move away from PowerPoints, and we've got competitors who are flying aircraft. We're starting to see these individual pieces of infrastructure together. So we said, hey, let's build something that brings all of those pieces together and shows kind of what the minimum viable product of a vertiport would look like.
Cool.
For the low price of 100 parking spaces outside of CES, I can build an entire airport infrastructure that allows our aircraft to operate, that integrates with other types of mobility where you've got the buses, the Tesla loop, electric car charging, micro-mobility, all these things brought together. So it's very much a real world experiment of this is what it looked like, and this is how people are going to interact in the space.
So this pavilion is intended to be a representative of a typical airport.
Absolutely, vertiport.
Yes,
absolutely.
I'll get the right word.
Well, I think I messed it up earlier too, so I want to make sure the marketing team has me use the right terminology here. But this is everything that you'll see here. So as we kind of go in,
So we're in a real vertiport.
yeah.
We're in. You just have to cut a hole in the roof and we're off to go.
Cut a hole in the roof or go paint a circle in the parking lot, and you're good. We could start moving, a couple thousand people throughout the day, landing here, having operations. People could sit and enjoy coffee. They could shop, or they could check into their aircraft and wait for their next transportation mode, as opposed to sitting in traffic for several hours, right?
Yeah.
It's not just about the time saving. It's also about the less stressful travel mode, right? That's the other thing that we can bring into all this process for us.
Sounds fantastic.
Yeah.
Looking forward to it.
So let me show you this next piece we have here. This is kind of our theoretical check-in process. We wanted to make sure and show people that we think this is going to be easy and straightforward, not like a current airport today. This is going to be something that you can walk into, check into your flight, sit down for a second as soon as your aircraft lands and charged, but it's going to be seamless as just walking in, tapping the screen, and going to your destination.
All of the rotors.
Let's go take a look at the aircraft.
Yes.
Let's go do that. So this is the star of the show here for us. This is S-A2. Back at CES in 2020, Hyundai unveiled their ambitions to enter into urban air mobility with S-A1. It was the original concept aircraft. Now, 4 years later, with a lot of engineering hours and a lot of help from our parent company of Hyundai, we've been able to mature that design to come up with a more optimized solution. This aircraft is going to fly at 1,500 feet. It'll go 120 miles per hour. We're going to optimize for mission set between 25 and 40 miles. That doesn't mean that's the entire range, but that includes your...
Sorry, I'm converting it to kilometers as you speak.
Yeah, of course. That includes your safety range, your reserves, and being able to abort a landing, go somewhere else, so that we ensure the aircraft can operate at its full capability.
So one way, about 40 kilometers.
Correct.
Okay.
It'll be 4 passengers plus a pilot, and we are planning to enter into service in 2028.
4 passengers, 1 pilot. Any thoughts of going autonomous entirely?
So we think that's probably more dictated by the regulations themselves.
Yeah.
And the aircraft is going to be designed to be upgradable and modular.
Okay.
So if we need to add in extra sensors or capability to support autonomous flight, we'll absolutely do that as the regulations persist or exist to allow us to operate in that case. And it's about safety. We want to make sure that we've built in autonomous systems that are well understood and well regulated to serve the public.
Okay, and so I see eight rotors.
8 rotors.
Some of which seem to tilt, or do they all tilt?
So that's actually kind of one of the keys to our configuration here. They all tilt. At no point in the flight of our aircraft are we carrying any unusable weight. So at takeoff, the rear propellers will tilt down, and the ones in the front tilt up. After we take off, they all start to transition into a horizontal configuration, and everything helps either lift or push the aircraft throughout all phases of flight.
Right.
Now the other nice part is, as we go through that transition, if they were all stuck like a drone, and to get forward flight, you have to tilt the drone forward. Instead of having to do that, the way the tilt mechanisms work, we'll be able to keep it more level.
Right, because your actual rotors are tilting, not the aircraft.
Absolutely.
Because they're not fixed in place.
Absolutely. So we'll be able to provide a better user experience again there as well.
And that's a full, operative, if you like, airfoil across them?
Yes.
Yeah.
Yes. So we can also we get a lot of range out of it once we're on the wing, and that's our most efficient use case. So we want to make sure that we're hovering as little as possible, and we're going to get on the wing and be as efficient throughout the entire phase of flight we can. I can probably get you guys up here to go take a look at it closer.
Can we actually get inside it?
They're very selective on who they actually let inside of it.
Oh, sorry. I'm selective.
It is unlikely.
I was selective breeding.
It is unlikely. It is unlikely. Let me go talk to our team real quick and see if I can.
Wait till they find out who I am.
You can't get in it, but you guys can come up.
Oh, we can't get in it.
Can't get in it. So the nice part about getting really close to it is we've worked really closely with our Genesis Design Center, who does all of the show cars for Hyundai, to create a aesthetic appearance and interior that's inviting and follows all of the design that Hyundai's become known for.
It's beautiful. It's a beautiful looking plane, let me tell you.
Watch your head as you're coming in, but you can take a look inside the interior. It's nice, it's bright, it's airy. We use a lot of light to help guide people into the vehicle. And you also notice the way the doors swing is intentional. Now, the reason we had it swing open this way was as people get in, we wanted to create a barrier from them to potentially walk into the rear propellers at any given time.
That's a good thing to do.
This funnels you into the aircraft in the most safe and efficient manner possible.
Can I get closer?
Yeah, you guys get in close.
I didn't want to.
You can get as close as you want. They just ask that we don't have people get into it. Yeah. Oh, no touching either.
Damn. Check out the.
Now, the other thing you can see is that we do.
I don't see any cup holders. Where are the cup holders?
Oh, they're behind the pilot seat right there.
Oh, yeah, I guess you're right.
There's also extra stowage in some of the center compartments and things that we're not allowed to touch. The seats are also in a track system, so we can reconfigure from a 4-seat to a 2-seat if you want to do a more luxury business version of it. You can also take that out and do cargo tie downs if you'd like to.
Nice.
Yeah.
So it's a 2 joystick operation.
Two side sticks. And no rudder pedals.
Yeah, I was noticing that. Well, because you've got everything on the joysticks.
Absolutely. And our teams are working together as much as they can to make this an easy aircraft to fly. Everything from how it flies to the computer systems that help you do it. It should be ideally a dream to fly.
So if I was a drone pilot, could I fly? How easy would it be to transition from flying a DJI drone to flying this? I got 2 joysticks.
That is a tough question. I can probably go find our chief test pilot somewhere, and he'll tell you.
You have a chief test pilot here?
We have a chief test pilot here.
Sweet. Because honestly, if you want to train pilots,
right,
and you got like millions of drone pilots hanging around wanting to get in here.
Yeah. I mean, the intent. Awesome. The intent is we want to make it as simple to fly as possible, and eventually we can get to the point where we're not having to get an airline pilot who's thousands and thousands of hours trained to do this. We can get somebody who's more like a mission manager at some point. Now that is not entering into service though.
No, but to start, he's got to be a regular pilot.
Of course.
He's got to understand all the rules, regulations, airspace, all that good stuff.
Absolutely.
It's amazing. So, how all props are this, or all the rotors are the same?
All rotors are the same.
They look like they're almost 2 meters long each.
I don't know if I have that exact number off the top of my head, but I can tell you the aircraft is 50 feet from tip to tip, including the rotors.
So 17 meters end to end.
It is 37 feet long.
Okay.
And it's 13 feet high.
Okay. That's cool.
Yeah. It'll be one of the safest aircraft on the market. We are designing to the highest commercial safety standards. So it'll be FAA certified, 10 to the minus 9th, no faults in a billion, or 1 fault in a billion flight hours is the intent. And we're also going to make sure that we address the EASA concerns as well. So there are some subtle differences between how EASA and FAA are certifying eVTOLs. So we want to make sure that we are meeting both standards to have the safest possible vehicle that we bring to market.
Okay. Now it's electric?
It's all electric, battery electric.
So where are all the batteries hanging out?
Batteries will be in the aft fuselage behind the seats.
Okay. Right, get your center of gravity's there. Okay, makes sense. And you said it has a flight time of, I can't remember what you said.
So it'll go 25 to 40 miles, so probably at 120 miles per hour is what, 15 or 20 minutes?
So about a 15-minute battery, well,
plus reserves.
Safe
Reserves
battery.
and things, yes.
Yeah. That's amazing. Beautiful.
Yeah, and entirely redundant. As part of getting to that 10 to the minus 9th, I mean, there'll be dual sets of almost every component on this aircraft to ensure that there's no single points of failure that will take you down.
But that's a good point. How many rotors can you lose before things go a little wonky?
Not certain we are saying the exact number right now, but we will ensure that we can operate with at least one motor having a fault in it.
Of course. Yeah. Obviously, you have to have that. Yeah.
Any other questions about the vehicle while I've got you up here?
No, I don't think so.
Actually, I haven't told you the most interesting part about it yet.
Tell us the most interesting part, Chase.
The noise.
The noise.
It'll be quiet, and the lack of noise, right? So in takeoff, in full powered vertical takeoff, it'll only be 75 decibels, which is a little louder than road noise. In horizontal flight, it'll only be 45 decibels, which is a modern dishwasher. It'll be barely imperceptible to background noise.
That's amazing, actually.
So that's how we integrate it into communities. Is it'll be battery electric, so there's no turbine noise, there's no whine. The blades are small, so the tip speed is low, so you don't get that whop that you get from helicopters, and allows us to make sure that we are a good neighbor with all the communities that we're entering into.
Very cool. Yeah, that is a good point.
Absolutely.
Yeah.
So what we decided to do was to bring a lot of the partners with us who are going to help turn this really amazing aircraft that we built and allow it to operate in the national airspace. So we've got partners who are helping us with low altitude weather and doing analytics on what is the actual climate that we're flying into, because it's a traditionally underserved area below 5,000 feet. So they distribute sensors across cities and will help make better weather models at a 1 kilometer resolution that are allowing us to see exactly what kind of flight times and what kind of flight characteristics we're going to be experiencing. You've also got unmanned traffic management systems, communication systems. How do you operate the vertiport, airspace surveillance, all of those things we wanted to bring into the exact same spot. So anybody who wanted to deep dive into any specific component of how this aircraft can operate in the airspace today and safely, we wanted to be able to have that conversation and have the experts here to do it.
Very cool.
Yeah, absolutely. And especially for a drone industry. So I think True Weather Solutions got started really assisting the drone industry, right? Because you're operating at lower altitudes, you're operating away from airports, you don't get great weather data, and you're extremely sensitive to the weather that's
micro weather.
To the weather you're flying in. So this allows us to have the highest possible visibility into what conditions we're going to be working in.
Now you mentioned that maximum was 1,500 feet, I think?
1,500 feet is where we will fly. It's where we'll cruise at. It can go up and down a little bit depending on geography and where we might be.
But you're
operating.
Staying out of the drone space of 400 and below?
Ideally, yeah.
Other than when you're taking off and landing, of course?
Of course.
Yeah. All right. Very cool.
Yeah. Any other questions?
When does it come to Canada?
When does it come to Canada? As soon as somebody buys one, and we'll ship it up there and start operating it.
Okay, where's my wallet?
And we take cash and Amex. No, I'm just kidding. It's we're trying to make sure we bring these things to market. So 2028 is when we expect to have a fully certified product.
2028.
And from there, we want to be able to bring any part of the ecosystem to you to make this thing happen.
Nice.
So if you want to set it up in Canada, we can have partners in the vertiport, in the airspace integration, airspace management, communications. We can get all those things and help them set up in your area, and then deliver our aircraft to start operating.
Nice.
Yeah, because it's an ecosystem.
Cool. Thank you very much,
Awesome.
Chase.
Thank
Wonderful
you, sir.
tour.
Yeah, you have a good one.
Yeah, you too. So Supernal, that was an amazing demonstration. I'm so pleased that we had a chance to get in there. Private tour, that was amazing. Looks like they've really thought it through in terms of the technology for the aircraft itself, the user experience, which is something you don't always see, as well as the whole control infrastructure. So yeah, cool solution, and I was really impressed by the whole tour.